Chapter 3.2 continues our discussion of exponents with one additional wrinkle, and that is the negative exponent. So I've given you a couple of examples here in the upper left. If you have x to the negative 4, in order to make that exponent positive, what you have to do is put it in the opposite position if you have a fraction. So x to the negative 4 then would equal 1 over x to the 4th. By the same token, if you have 1 over x to the negative 4, to make that exponent positive, you would come up with x to the 4th over 1, or just x to the 4th. That's the basic rule. And they talk about negative exponents because negative exponents typically imply something that's very, very small. They use that in scientific notation, and we'll discuss that at the end of this lesson. Anyhow, let's take a look at number 4. Number 4, being like our first example, if you have x to the minus 8, the answer to that is just 1 over x to the 8th. If you take a look at number 8, that's the total quantity, negative 2 to the negative 4th power. That's the same thing as saying 1 over negative 2, that whole quantity to the 4th power. Now, what's negative 2 times negative 2? That's a positive 4. Times a negative 2 is a negative 8. Times another negative 2 gives us a positive 16. So that's 1 over 16. Looking at now number 16, you'll notice that it says negative 5x to the negative 2 power. That negative 2 power only pertains to the x because that negative 5 is not inside the parentheses. So that negative 5 just stays there, and now it becomes over x squared. All right, so you have to be careful about what you're moving. You only move what that negative power relates to. In this particular case, it was only the x and not the 5. Looking at number 20, and I'm going to move this down just a bit here so we can look at it a little better. Now we have 3 over 4x to the negative 4th. Notice again, we have the 3. We're not doing anything with that, so that's going to be in our numerator, okay? That x to the negative 4th, it only pertains, that exponent only pertains to the x that's with it. Doesn't pertain to anything else. To get that to be positive, we have to move it up into the numerator and make it x to the 4th. And then we put the 4 down there by itself. So it could be 3/4 x to the 4th or 3x to the 4th over 4. Both of those answers are acceptable. In number 24, we have two ways of looking at that. If you took a negative 4 and added it to a positive 5, you combine those, you get y to the 1st. Or if we did this, y to the 5th stays the way it is, and we put y to the 4th underneath and make it positive, like that. Now both our exponents are positive, but we've got y to the 5th divided by y to the 4th. 5 minus 4, just y to the 1st, or y. Looking at number 48, now we've got this whole quantity taken to the negative 2 power. So why don't we do this? Why don't we take it 1 over this whole quantity? Oh, excuse me for that. P to the negative 3 q squared, and that whole thing now is squared. This then becomes 1 over p to the negative 6 q to the 4th. But we are not allowed to have any negative exponents. That p needs to come up into the numerator in order to make it positive p to the positive 6th over q to the 4th. So it's pretty simple just maneuvering these things back and forth between the numerator and the denominator. Let's take a look at number 74. In number 74, what we have is negative 5 times the 5a to the negative 2, b to the negative 4 times 2, a to the 5th, b to the 0. All right, so let's take those two numbers, 5 times negative 5 times 2. We come up with a negative 10. And now we have an a to the 5th, a b to the 0, which means almost nothing. It's the same thing as 1. And now, down below, we take our two negative exponents, which are a, and since it was negative 2, now it becomes squared. And b, since it was negative 4, now becomes to the 4th power. All right. The b to the 0 power actually is the same thing as saying 1, but then again, by the same token, that forces the b to be down in the denominator. So I'm just going to scratch that out. And now what we have is a to the 5th over a squared, and when we subtract those, we'll get negative 10a to the 3rd power, and our b to the 4th remains in the denominator. So it looks like that, 10a cubed over b to the 4th. Now we want to talk about numbers 84 and 88. This is scientific notation. If we have 8.23, and in scientific notation there is only one numeral left of the decimal. That's the way it always is done. Any more numbers that they have will be placed to the right of the decimal. 8.23 times 10 to the 3rd is the same thing as saying 8.23 times 10 with 3 zeros. And as we learned a long time ago, in order to do that, all we have to do is start moving our decimal point to the right, however many places it says. In this particular case, it's 3 places. So it's 8, 2, 3, and one more place makes it 8,230. In number 88, we have 7.5 times 10 to the negative 6, which would be the same thing as saying 7.5 divided by 10 to the 6th. However, the way we look at it is we'll take that 7.5, and instead of moving it to the right, now we're going to move that decimal to the left 6 places. 1, 2, 3, 4, 5, 6. But we have to fill in a 0 for every one of those. So it's 1, 2, 3, 4, 5 to get it moved. So our answer then turns out to be 0.000075. And that's how to do those problems. Shouldn't have too much difficulty with these. It's just one more added concept to what you had in 3.1.